another LeetCode video today. So we got valid anagram. It's a LeetCode easy. Going to be doing it in C++ as always. So yeah, let's get into it. So given two strings S and T, we're going to be returning a Boolean value. We're going to be returning true if T and S are anagrams, and then false if otherwise. So S and T, yeah, two parameters for this function, both strings. Basically just comparing them to see if they're anagrams. You might be wondering, what in the world is an anagram? Well, thankfully they gave us this definition here. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So basically, yeah, for this the context of this problem, typically you can just be ignored. We need to use all the original letters exactly once for it to be an anagram. Luckily for this problem, it's restricted to just lowercase English letters. So this is actually like an important constraint because like you can improve the speed of this function significantly with this in mind, because if this was like a bunch of different characters, we'd probably opt to use a hash map just for easier, cleaner code. But since it's just it's literally just 0 through 26. Maybe you're catching the drift by now, maybe not, but basically, since there's only 26 elements and they're represented by individual characters, we can literally just tie them to pretty easily map them to integers. And then, since we can map the characters to integers, we could just use a normal old array instead of a hash map. And that's like way faster, quite a bit faster. So looking at IO here to just get a more kind of understanding on what an anagram is. So anagram and this nagaram, those are anagrams of each other, because you can see that each letter is like used exactly the same amount of times in each of these strings. And then like for rat and car, they're not anagrams because they contain different letters. But like rat and tar would be, and art, those are all anagrams because you can rearrange those letters to form different words. So I'm just going to get straight into the optimal approach this time for this problem. So the optimal approach is going to be basically map characters to integers to take advantage of the speed of array, of like C style array. So and then with that in mind, our time complexity is going to be just big O of n, because it's going to be linear, because we're just using for loops. There's no nested for loops, no like sorting or anything weird. And then our space complexity is just going to be constant because we're going to be using the same size map every time. It's just going to be it's going to have 26 elements for each of those characters. So to go ahead and start writing the solution, we're just going to need first we can declare that array of integers that we'll be using for our like quote unquote map. So we'll say int map, and then give that a size of 26 for each of those characters. And then the way we can initialize those all to 0 at first is with this sort of syntax. And the reason why we're initializing these to 0 is because we're basically going to take string S, and then every time for each character in string S, we're going to increment at that character. And for the characters in string T, we're going to decrement at that character. And then basically, if they're anagrams, the way that works is like all of the values after this process should be 0 if they're anagrams. If they're not anagrams, it's the characters could either be skewed negatively or positively. And I'll kind of show that more here. So basically, to loop through each of the characters in string S, we can just say for char C in S, and then we're going to increment at this character for the map, and I'll come back and put the, how we're actually going to map those characters to integers in a second. But first I'll show this kind of high level overview of what we're doing. So we're going to be incrementing for the characters in S and then decrementing for the characters in T. And then the way we're going to map this is you can actually just subtract. So like if we were to just do map C, this wouldn't make sense because A doesn't have, the lowercase a doesn't have an integer, doesn't correspond to an integer value of 0. It corresponds to like some higher number. But the way we can fix that is we can just subtract the character value A, from whatever character this is. So like if this was A, then you get the index 0. If C was B, you get the index of 1. If it was C, you get the index of 2, etc., like all the way to Z to get the index of 25. So we're gonna do that also for the to map the characters to integer indices in T, and then basically once we've done that work, that's like most of the work there, we can really just go through the map and check, just pretty much see if all those values are 0. If any of those values aren't 0, like we immediately know that we don't have strings that are anagrams of each other. So let's just loop through all of those numbers in the map. So we're gonna have int, I'll just call it int x in nums. For int x in nums, basically going to be checking if x does not equal 0, we know immediately we can just abort from this whole thing. Return, we don't have to check the rest of them. Like we know if one of the characters is like skewed, negatively or positively, it can't be an anagram. It's impossible. So return false. And then, to return something in all control paths, we return true, because, we'd only get here if every single one of those, values is 0, in which case we know for sure we have 2 anagrams. So let me just look at this real quick once again to make sure there are no bugs here, typos. Doesn't look like there are, so I'm going to go ahead and run this. And let's see, for int x in nums, so use of undeclared identifier. Yes, I meant to say maps, or map, sorry. Because we're iterating through the map array. Okay, so that should be good there. And as you can see, it's accepted the 2 test cases. So I'll just submit this as always so we can see the percentages. 3 milliseconds beats 97%, so I'd say that's decent. Yeah, so I hope this helped you. Hopefully the explanation was straightforward enough. If you want to keep seeing more of these videos, please like it and leave a comment. Suggestions are also super helpful because I'm trying to learn as well, just as well as you are. So yeah, thanks for watching, and I will see you in the next video.